Hey guys, this is T here doing a quick video on linear relationships. This should be helping you out with exercise 12a. So in maths, when you're talking about a relationship is between two variables, and a relationship is a specific rule that applies between those two variables. That rule never changes if they've got a relationship, and the rule can be used to find one of the variables if the other is unknown, and that's because the rule doesn't change. So a quick example would be when you take a taxi, the cost of your trip in the taxi depends on the distance that you travel on that trip. So if you had a table of the distance travelled and associated cost, it might look like this: distance travelled. So for 0, you'd pay 5, so you have to pay $5 just to get into the thing, even if you don't go anywhere. Distance of 1, you'd pay 7. Distance of 2, you'd pay 9. Distance of 3 kilometres, you'd pay $11. Distance of 4 kilometres, you'd pay $13. So you can see that there's a relationship between the cost and distance travelled. If you'd work it out, the relationship is defined by the cost is 2 lots of whatever the distance travelled is plus 5. You can see that because it applies to every single one of these costs. If you times the distance travelled by 2 for 0, or 2 times 0 is 0, add 5 to it, the cost is 5. If you times the distance travelled here, 1 kilometre, by 2, that'll be 2, add 5 to it, it's 7. If you times the distance travelled of 2 by 2, it'll be 4, plus 5, it'd be 9. So that is the relationship between them. So it might be useful at this early stage to get the hang of finding the relationships there. You can use trial and error. If you can spot it straight away, that's fine. You can use algebra. But that's not what this video is about in particular, because what the main point of this video is that you should notice that these costs are increasing by the same amount each time. It's increasing by 2, 5, 7, 9, 11, 13. Also notice that the distance travelled is going up by 1 each time. So for every increase of 1 in distance, you're getting an increase of 2 in cost. So if you have a relationship where the variables increase by a constant value, so this one's increasing by 1, it's going up by 1, plus 1, plus 1, plus 1, plus 1. This one is also increasing by constant value, plus 2, plus 2, plus 2, plus 2. If they're both increasing by a constant value, the variables have a linear relationship, and that's what this video is about. What is a linear relationship? It's where the variables are both going up by a constant amount each time. It's predictable. So a kind of question you might have to answer using the taxi fares table above. A, extend the table to include up to a distance of 10 kilometres. So I'm going to quickly redraw that table. Distance, D kilometres, and cost, $C, and I'm going to have to extend it to a distance of 10, so it might have to be double that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So distance 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then lastly 10. And we already know 5, 7, 9, 11, 13. It's been established that they're going up by 2 each time, so that'll be 15, 17, 19, 21, 23, 25. So we've done A. B. Find the cost of a 7-kilometre trip. Well, we've extended the table now past 4 kilometres. So to answer that question, we just need to look at which entry in the table is 7 kilometres, which is this. Find the cost of it. It's going to cost $19. So $19 for a 7-kilometre trip. C, find how far you could travel for 25. So looking at the table, this is the cost of 25, so I could travel for 10 kilometres. Therefore, 10 kilometres for $25. So you can see those are examples of what I've set up here. The rule can be used to find one of the variables if the other is unknown. We've established the rule. We used the rule to draw the rest of the table out there, and so we didn't know how far you could get using a $25 trip, but knowing that the relationship is constant, we had a look at $25 of money will get you a 10-kilometer trip. So that is linear relationships. That'll help you out with exercise 12A. Hopefully it helps you out, and see you in the next one.